Today we're going to be taking a look at binary search trees. When you first open up the HTML, you will notice that the UI is the same from the last video. And it's just because a lot of the components that were needed were very similar to the last ones. So I decided to just keep that to make things a little bit easier. Alright, let's get right to demonstrating it. So as you'll notice, when you first open it up, here is the output. This is where you will get to see everything related to the search tree. And then again, down at the bottom is the input. So this is where you're going to be able to insert things, find things, delete, and display information within the search tree. Let's just go ahead and do a quick demonstration. So when you first open the web page, it will automatically put 5 different items in the inventory, and I will show you that now. In order to do that, you will notice the 3 checkboxes. Those are for the 3 different ways that you can go through a search tree. I will go a little more in depth whenever I actually look at the code, but for now we'll just go ahead and select all 3 of them so you can see. So as you can see, there's 5 different things, and with each one of these they kind of go in a different order just because of the way that it goes through the search tree in order to display the output. Now let's try adding something. I'll just type in whatever number I want, 152,555. Alright, now, and since it is an inventory, if you'll notice there is an ID and a name. So you have to actually put a name with the ID, otherwise it won't accept it. So, put in that, and we'll put in whatever name we want, or, I don't know, we'll just put cord. So for like a charger or something like that. We're going to insert it, and you will now see that it was inserted with the name cord. If I want to find that item, it's already in there. Obviously you would just retype it in with just the ID. It found the item. If I want to delete designated item, it deletes it. And I probably should have showed you before that it was in there, but it is gone, which we can easily just put it back in there. Oh, right. I forgot. My bad. Insert. There we go. Now we can display. Alright, so now you'll see that it is now here at the end of the first 2 and in the middle of the second 2. Alright. Oh, one more thing. Find max. So this is going to look for the highest value within the binary search tree, which in this case is the one that we added because it's the only one that is above 110. If I delete that one and do it again, 110 becomes the max just because of the default values. Alright, let's go take a look at the code. Alright, so when you open up this, you will notice the very first thing is the class called node. So this is going to be the actual nodes that are within the binary search tree. So this is just setting up what each node will have within it. So in this case, it's got an ID and it has a name. So you have to assign those values based on the information that it pulls in. And then with nodes in a binary search tree, nodes can only have, or well, I guess parents can only have 2 children. So for the sake of this, we did left and right. That's how you can determine where it needs to go as far as putting it in the tree. You want to make sure to set that to null. That way it defaults it to not having anything as far as children. Next up, you've got the BST class. It's going to start by setting up the root node within a private so that it can't be accessed outside of the class. That is for security purposes, so other people can't, adjust the root and screw things up. You then have the constructor, which is going to initialize the root as null, which is just going to set up an empty binary search tree. Then you have the insert method. So this one is going to call a recursive method that starts at the root to add the new node that you are trying to add. So if you want to add a computer to your inventory or whatever, you type in the ID and the model name, or whatever you want to call it, the brand or whatever, and then it's going to go through and set that first one as the root. You then have the insert rec. That is the recursive method for actually inserting a node. So this one up here is just using this function down here to be able to put in the root. So down here, this is going to be checking the current location within the binary search tree. It's going to check to see if the current node that you are actually at is empty or not. If it's empty, it will simply put the new node that you are trying to put in the search tree in that spot. If it's not empty, then it's going to check to see if the ID of the new node that you're putting in is less than or greater than to the current spot that you're at. If it's less than, then it will move to the left child of that node. If it's greater than, it moves to the right side. It will then return the new current node, and it will continuously do this until it manages to find an empty node to place it in. You then have the find method. This takes in the ID, and it's going to call on the find rec, which is the recursive search method, which will start at the root of the thing, the search tree, sorry, and then it's going to return the node that it found if it finds it, of course. You have the find rec. This one is going to check to see if the current spot again is null, or if it is at the beginning. So it's going to start at the beginning. It'll check to see if that's where it's at. If it's not, then it'll move forward. If that is the case, then it will return that as the current. Okay, so if those are not true, then it's going to again go through the list, starting on the left to see if it's less than. If it is, it will go down, and it will continuously do that, going to the left or the right based on the values to find the proper one if it exists. You've got the find max. So this is calling upon the find max rec, which is this function down here. It will set that max node to that and then return that. So it will check the root to find that and then return it so then it can be displayed. You've got find max rec, which again is going to check to see if the current spot that you're in is null. If it is, it returns null. It's going to continuously go to the right child until it manages to find the end. If once there is no more, then it's going to return that last node that it got. With the delete, this is going to call upon the delete rec, which is another recursive method, in order to delete a function delete a node based on the starting point from the root, working its way down the tree. It's going to check if current is null. If it is, it returns that as the current node. If it's not, then it's going to again check to see if the new ID is less than or greater than the current ID, and will continuously go down until it finds the proper spot. And once it does that, it will actually look to see if the current spot that you are at is the same as the one that you were trying to delete. If that's the case, it will delete, obviously, because if they have the same value, I mean, you want to delete the one that has the same value. Down here is where you have the different use cases for being able to determine where it needs to go as far as delete and how it needs to rearrange the data to delete. So it's going to check to see if it has a left child. If it does, it's going to then check if it's got a right child. And then if it has both children, it will find the minimum value from the right tree and replace it with the one that you are currently at, and then delete the one that you just put up at the top. So let's say the minimum value on the right, so the minimum of the highest values of those two will be, let's say, 27, okay? And your current value is 33. It's then going to take that 33, delete that, replace it with the 27, and remove the 27 that was down at the bottom. So that way you don't have any issues. We've got another recursive helper method. This is for finding the minimum value. I don't think I actually implemented that yet. I apologize. I think I forgot to put that button in there. That was my bad. So essentially with the minimum, it's just going to do the exact opposite of the maximum. So instead of going down the right side of the tree, it's going to go down the left side of the tree until it finds the lowest value in the search tree. And you've got the traverse. This is going to get the different order type. So it's got a switch case because of the fact that there's 3 different ways that you can go through the search tree in this case. You've got the in order, the pre-order, and the post-order. So with the in order, that one is going to start at the left side of the tree, work its way up until it gets to the root. It'll give you the root, and then it'll go down the right side. With the pre-order, it's going to start with the root, make its way to the left side of the search tree, and then go to the right side of the search tree. With the post-order, it goes from the left to the right, goes through the left side, goes through the right side, and then gives you the root. I think that's all for now. We'll see you guys next time.